Alright, so this was two-sided. If you didn't get everything done, that's okay. Remember, when you get these, you should be working on them, not just waiting until I do them, because that doesn't help you. I know this information already. Alright, some of these you need to do algebraically, but all of them you could have checked in your calculator or Desmos afterwards, yes. Yes, you missed that. Alright, so for the first one, 0, remember, is another word for x-intercept. You need to put 0 in for y and solve. So f of x is the same thing as y. Replace that, put 0 in, solve for x. Subtract 4 to both sides. Multiply both sides by the reciprocal of this. So then that becomes positive 1. What you do to one side, you have to do to the other. This becomes positive 12 over 2. Questions on number 1? Number 2 said it's already giving you this graph. Really, this line is, or this equation is this line right here. And it's asking for the solution. Solution is another word for 0, x-intercept, root. So all you have to do is look and see where does this cross the x-axis, and that would be at 2. Negative 2, sorry. For number 3, I think this was one I said put it in your calculator or Desmos. So really quickly, I'll put it in Desmos. And it asks what are the roots. Roots is another word for zeros, x-intercept, solutions. So the 2 you had should have been at negative 1.5 and positive 2, or negative 3/2 and positive 2. Really quickly, if you wanted to see that on your calculator, if you go into y equals, put in that equation, 2x squared, just use this button for your x, the square button, minus x minus 6, and you hit graph. Oh. But it does go in between -1 and -2, and it does look like it's on 2. If you wanted to see that exactly, you could go into trace, and you're looking for zeros, you would go into number 2. And then it asks you for like left bound, right bound. You're basically going to put lines around the 0 you want. So if I'm looking for this one, I would say the left bound would be something over here, so I could say like -3. I'm going to put this blinker here, and then I want the right bound to be somewhere on the right of it, so I can say like 0. This is, if I wanted to guess, I don't, so I would just hit enter, and it would tell me. In between those two numbers, I said, is the 0 of -1.5. Then I could do the same thing for the other side. The second trace, go into a 0. I'm looking for this right x-intercept, so the left bound I could say is like 0. The right bound I can pick any number past the number I want, so like 5. And it would tell me that that 0 is 2. I meant to show you guys that, well, I just got this like Friday after I saw you guys. So if that was too fast or you need to see that again as you're doing intercept stuff, just let me know and I can go back to that. One of these I said ignore. That one. So we're not doing number 4. We're going to do one similar to it on the other side. I'm sorry, similar to 5, I meant. So for number 5, it asks what value of k is the 0 of h of x equivalent to the 0 of g of x. So first, I would need to see what is the 0 of this equation by figuring out what that is. So set g of x equal to 0 and solve. To get rid of the 1/2, I would multiply both sides by 2, or 2 over 1. So I can say the 0 of g of x is 6. So for this one, in order for x to equal 6, I'm going to put that in and put 0 in for y and solve that way. Because I know the zeros need to be the same. In order for it to be a 0, y needs to be 0. To solve for k, I would subtract. So if k is -18, then when I solve for 0, I should get 6, and I could check that. So if I put 0 back in here and I solve for x, I should get 6. So add 18 and divide by 3. They have the same 0, so that works.
Actually, let me make sure a pass to go down there.
For the other side, number 1, put all of those in the Desmos like at the same time. Or you can do it one by one, either or. I'm going to put them all in at the same time. I'm looking for which of these have an x-intercept at 3. You can see that 3 of these things go through that point, whatever the green one is, the purple one, and the red one. So I can get rid of the blue one and the red one. Nope. And the blue one. So those 3 have an x-intercept at 3. 2x minus 6, x squared minus 9, negative 3x squared plus 10x minus 3. So you can star circle those 3. When you if you were to put those in your calculator, it would do the same thing, but you wouldn't be able to see them color-wise, so it would be a little difficult. The number 2 on this page is very similar to the number 5 we just did, so we're not doing that one. For number 3, we need to write the x and y-intercept as an ordered pair. The y-intercept we don't need to solve for because we gave it to us. The x-intercept you did need to solve for. The 0 equals 3x minus 4, add 4. And divide by 3. So our x-intercept would be at 4/3 0. Number 4 asks about the y-intercept. So those can interchange at any point. Just make sure you're reading that. If you solve or look for a y-intercept when you're looking for an x-intercept, or vice versa, it'll be wrong. The y-intercept was right here. I don't know if you were clear. You're having to see it. And then the last one, you're looking for which one of these has exactly one x-intercept. So again, put them in the decimals in your calculator. If it touches at more than one place that doesn't have one intercept. If it doesn't touch at all, it doesn't have one intercept. So here, as I'm looking at these, the blue goes through it twice, so that's out. The purple doesn't touch the x-axis at all, so that's out. Both of these touch the x-axis exactly once. This one goes through it only at one place, and this one touches it just at one place. So both of those would be your answers. x squared minus 6x plus 9, and negative 3x plus 1. All linear functions only go through x or y-axis once. But things that have two x's, those are iffy. You have to look at them to see it. Do we have any questions on any of those? We're going to start the notes, but we probably won't get very far, and then we'll continue tomorrow. Your note should look something like this. Mine are partially filled in, so I'll let you fill those in as well. So it starts off with a rate of change. That should be something that should be familiar to you or review for you. But when we talk about a rate of change, that's like one slope should come to mind when we talk about a rate of change. But it's a ratio that shows how one variable changes with respect to the other. Really, how does y change in respect to x? So on a graph, this is called the slope. Rate of change is slope. How does y change in respect to x? Slope is written as that ratio to reflect a vertical change, a rise, to the horizontal change run. So we're always getting up before we move, up and down before we go left and right. Between any 2 points on a line. This remains constant for any 2 points on the same line. So between point A and point B, whatever that slope is going to be the same as between point B and point C, point C and point D, and so on and so forth. And then anytime we write slope, it is a ratio, but we're going to write it as a fraction, which are also ratios. In simplest form. And the variable that corresponds to slope is m. There are 4 different types of slope. Does anyone need this? I just didn't want to move it. There are 4 different types of slope. I'll let you write these words first and then I'll go on. One's going to be positive, one's going to be negative. You're going to have a 0 slope, and then you're going to have a slope that's undefined. If you have a positive slope, as you're reading from left to right, it's going to go up and to the right. If you're reading from left to right. If you're reading from right to left, it's going to go down and to the left. Consider down and left both negative things. A negative over a negative would still be a positive, so that still works. A negative, if reading left to right, would kind of be the opposite. It would go down and to the right. So down would be the negative, but right is that positive. One is negative, one is positive. Or if reading right to left, you would go up and to the left. Up is positive, left is negative, so there's still 1 and 1. If you have a 0 slope, it's going to be a horizontal line somewhere where there is no change in vertical, and there's no vertical change. But you can go right or left. Think about that as driving, walking, bicycling, something you're doing on a straight path, speeding, etc. Undefined slope is something like going up and down in an elevator, bungee jumping, falling off the cliff is the only other thing I can think of. Something you're doing straight up and straight down, where there is a vertical change, but there is no horizontal change at all. Sitting straight up, sitting straight down. So when we're looking for slope on a graph, one, we're trying to figure out which of these it is, positive, negative, 0, undefined. But also, what is the slope, to find the actual numerical value. So the easiest way to do this is to look for 2 points that cross grid lines exactly. Now, these points are drawn in. I can see that this point and this point cross the grid lines exactly. But if I didn't see those and I was looking, I could also look at this point. This way. I don't think that was in that. I think the next one has actual points, that one does not. The paper sometimes throws it off as well. So I would just say be careful when you're looking for points. And then you're going to count. So always up or down first. So if I'm doing left to right, I'm going to count how many units up. 1, 2, 3, 4, 7. And then how many units to the right. So I went up 7, to the right 4. Positive over positive, it's going to stay positive 7/4. If I went the other way, let's say I'm now reading right to left, up or down first, so the only way I can go is down, so I can go down 7. And to the left 4. Remember, I think down and left are both negative, but if I have a negative over a negative, it still becomes a positive. Either way you look at that, you're going to get a positive slope. Do you have any questions on? Do the same thing for number 2. I see there's a point here and here. If I didn't see those points, I could also do this point right here and this point right here, or these 2 points, or these 2 points, or some combination of any of those. Because you would need to simplify at the end anyway. Good morning. So let's say I just looked at the pink points first. I would count down however many units. And then to the right, however many units. 3, 4, 5, 6, 7, 8, 9. I can simplify this, so I would get negative 1/3. If, let's say I just saw these 2 points first, and I was reading right to left, I would go up 1, and to the left 3. I would still end up with that negative 1/3 either way. So it really just depends on what points you see, and you have to remember to simplify always. Questions on that one? These last two, and those will be the last things we do today. So, one way to kind of remember which one is which, and this will make even more sense when we get into graphing, which slope is which. I use these letters. Bucks, which means if I have a horizontal line, I'm going to have a 0 slope, which is going to be the y=equation. The y=equation we don't really need right now for slope. We'll need more for when we graph, when we write. But if I remember which way is horizontal, left to right, then I know that this will be a 0 slope. Could you still count the points? Sure. I see that I have a point here, I have a point here. I don't have a vertical change, but I have a horizontal change, which I know you look at. But 0 over anything is 0. So you can count it, but you don't have to, because it will always be 0. The other one is vertical, so up and down. Undefined slope, x=. If I know I'm looking at a vertical line, I should have an undefined slope always. And to shorten it, you could just put u and v. Again, you could do the counting. I see I have a point here and a point here. My vertical change, let's say I'm going down 5. But I'm not moving left or right. If you were counting, you would need to double check this. If you were to put this in your calculator, for someone that has a calculator, -5 divided by 0. What do you get? Error. It doesn't work. You can't divide by 0. So it's undefined. Because the quick check kind of ran over, I asked if you guys had any Delta Math or Khan Academy questions, but then didn't go over any. So if you do still have some, bring those to class tomorrow. We'll go over those. We'll continue these notes tomorrow. You do not have any homework from me today unless you did not finish the Delta Math and Khan Academy for intercepts last week. Please remember this. I know Delta Math is informative, but it is practice. You only get better at math if you practice. So you practice them.